Let's create another table now, and let's call this table Maths. And this table is going to have two columns, and the purpose of this table is to introduce two more column types. First one, let's call it column F, is going to be of type float. And what a float column type is a floating point number. Floating point number allows us to use fractions and a certain method of notation that you may be familiar with from mathematics that allows us to store very large numbers. However, certain accuracy is lost using the floating point data type. We can also specify double, and this is twice as precise. In other words, twice as many actual digits are stored when the number is converted to a floating point number, if it becomes sufficiently large. This may not make a terrible amount of sense. So let's look at an example. If we insert into the maths tables values, let's take very simple values, then it will effectively act as if these two floating point column types were integers. It won't look any different. The numbers have been added just the same way as they had been were they integers. However, if we insert 1.23, we can see that the floating point column type is able to deal with fractions as well as whole numbers. Another way in which it differs is if we use a long numbers such as this, then we'll see a difference in the way these figures are stored. As we can see, when the number becomes large, the decimal point is moved right to almost the beginning of the number, and then the number of places that the number is away from the decimal point is given at the end. As we can see, the floating point column has resorted to this method because it's run out of digits that it's able to use, whereas the double has not. If we insert an even larger figure, into our maths table, we can see that we've effectively forced both of them to show their numbers as floating point numbers. The disadvantage, of course, is that as the numbers get bigger, we lose some degree of accuracy because only the first set of numbers, of digits that are stored, are remembered. So the smallest figures on the lowest place value tend to be lost as your numbers get bigger. There's also one more kind of numeric column type. And let's create a new table for this. And we'll call it price list. And I'm just going to put one column in here, and I'm going to call it price. And the reason I've given this table and column a more meaningful name than the others is that the decimal column type, which is the type we're just about to learn, is particularly suited for this kind of data. For instance, when we have a price listed, if we wish to add $3.50 to $2.50, we want to make sure that the cents are still mentioned, even if they're completely empty at the end of the sum. How we can do this is to specify after the decimal column type, in brackets, First of all, a number that represents the total number of digits we want to be able to store in the column. And then we have a comma, and then the number of decimal places that we want to have after the decimal point. Then we'll close a bracket that encloses the list of different columns in our table price list, and then we're going to try out the decimal column. So if we just insert the value 3, then we bring it back with the select statement, as you can see, it's added 2 decimal places after the decimal point, just like a price or an amount in money. There are other uses for the decimal column type, but this is probably the most common. You can also allow for, if we have a number that is too precise, a fraction that is divided too small away, as we can see, it's rounded it up and it's included it as a standard 2 decimal place price. These are the numeric column types for MySQL. There are also 3 more column types: date, enum, and set. We're going to deal with those in a later chapter, because in this chapter I want to get you to grips with the very basics of SQL. And so in our next movie, we're going to look at some more SQL commands to manipulate your data.